Testing, testing. All right. Hey everybody, welcome to Building Applications with Infrastructure as Code. My name's Talia Nassi, and let's go ahead and get started. So I am a lead developer advocate for Akamai Technologies, and my job is just to build things in the cloud, and then I talk and write about them. Before becoming a dev advocate, I was a test engineer, so I was responsible for QA, automation, testing, full end-to-end tests, integration testing, all of the, basically every part of the testing cycle. Before Akamai, I was at AWS on the serverless team. Before that, I was at WeWork. I was a test engineer at Visa, so I've worked at some pretty corporate companies. I've also worked at smaller companies. And something that I want to talk about today is infrastructure as code, because it relates to a lot of different companies and a lot of different scales. You could be a small company, you could be a big company. But I want to go through an introduction to infrastructure as code and really understand the use cases and the why and what some of the benefits are. And then we'll talk about some tools, and then we'll go through a quick demo. So many times when developers start building applications in the cloud, they'll start in the console, right? So you choose the services you want and then you connect them. You build your Lambda function here, you choose what you want as a trigger for your Lambda function here, what do you want as your destination, you have maybe a database connected, maybe a server, and you can create all the resources you need right there from the console. And this is a really great way to learn, right? Because you have this UI where you can see everything that you have in your application. The only problem comes when you want to move your resources to different accounts, or you want to move it from one environment to another, or just somehow replicate what you've done in the console. So chances are you're not going to know exactly how you set up these resources in the first place and exactly which configurations you set. And so to solve this problem, we're going to look outside of the console to something called infrastructure as code. So with infrastructure as code, what you're doing is you're automating this provisioning process. So you're not going to go to the console, click on the services you want, configure the resources and everything from the UI, from your cloud provider. What you're going to do is you're going to create something called a configuration file where you define all the resources you want and all the configurations for those resources, and that's how you instantiate your infrastructure. So in this configuration file, you have one place with all of the steps and configuration for your application that you can reuse whenever you need. And the great part about this, and kind of the highlight of this, is that you treat your configuration files and your infrastructure as code. And so what are some of the things we do with code? We version it, we put it in a repo in GitHub or code commit or something like that. And then you deploy a version and you work on it, and then you merge a new version, and then you can roll back if you need to. So when you move into this new way of working with infrastructure as code, you treat your infrastructure the same way that you treat your code. So if something breaks and your infrastructure isn't working, you roll it back to a different version that was working, or you try a new version, or you can move it over here to another environment. You have this flexibility to build, change, and manage your infrastructure in a safe, consistent, and repeatable way. So why is this important? Why is building with infrastructure as code better than from a UI? So by using the same configuration files, you ensure consistency across these environments. And this takes care of that, well, hey, it works on my machine phenomenon. You have one source of truth, that's this configuration file. And this happened a lot when I was a test engineer. I would see this all the time where I would open a bug, I would find something wrong and I would, take a screenshot and write a defect report, and then I would send it over to the developers to say, hey, this is what's going on. And they would respond with, oh, well, it works on my machine. So this is something that you see a lot in the software development lifecycle between dev and QA. It's something that you see with customer success when they're trying to reproduce an issue that happens in production. So it happens a lot across many different teams, and this is one of the ways that we can combat that. It's also really great for onboarding developers. So like when a new developer joins your team and they're setting up their environment, let's say it's like their first day, and they get like this whole book of like, okay, this is how you set up your environment, and it's like 3,000 pages of like this deployment and that deployment, and you have to set up all these tools, and it's just really overwhelming. Versus when you're using infrastructure as code, all you have to do for the new developers joining your team is just give them the configuration file and say, hey, deploy this, done, like everyone's happy. Another benefit to infrastructure as code is that it eliminates configuration drift. So configuration drift happens when you have a shift in environment. So let's say there's an incident late one night, like really late, and there's an incident for your mobile application, and you look at the logs, you identify what the problem is, and in order to fix it, you need to update a specific configuration in production. So you make the change in production and you go back to sleep. Although you fixed the issue, you've just created an even bigger divide between your staging and production environments because you didn't make the same change in your staging environment. So many times staging environments are not the same as production because of changes made during incident management, and this is called configuration drift. So with infrastructure as code, rather than having that shift in environments, you have one central authority that is this configuration file, and then you just push the infrastructure changes through. It also decreases risk. So provisioning all of your infrastructure by hand really is risky. It requires a lot of manual work that's error prone. It might require like one single person to do, and like, what if that person leaves the company and they take all of that knowledge with them? So infrastructure as code really minimizes these risks. And so by representing infrastructure as code, you have these reproducible blocks of code, which are far less error prone because your infrastructure lives in a source code repository, and all of its history and its changes are visible to everyone on the team. So how do we actually implement infrastructure as code? I talked about this a little before with what we call configuration files, and we're going to talk about some of the tooling later, but one of the tools you can use is called Terraform. Terraform is an infrastructure as code tool that you can use for defining both cloud and on-prem resources in these configuration files. So I want to take a look at one of these configuration files as an example. So one of the most important things to note with configuration files is that they are declarative, meaning that they describe the end state of your infrastructure. So you don't need to write step-by-step instructions to create these resources because the infrastructure as code tool will handle that logic. So I don't have to go in and say, hey, create this IAM role and then click over here and go to this button and then click on, like, I don't need to say how to create these resources. All I have to do is list them in the configuration file, and you describe what, like, the overall topology, right? So when you deploy the configuration file, these resources are going to be either created if they're brand new resources, updated if they already exist, or deleted if you remove something from the configuration file. So in this example configuration file, we're saying, hello, please create this IAM role with these configurations, and please create this Lambda function with these configurations. Thank you, have a nice day. So I don't need to say how to create these resources. I don't need to give, the infrastructure as code tool, specific instructions or anything like that. Your cloud provider will handle this logic to create or update the resources that are in the configuration file. There is a core workflow for creating and managing this infrastructure, and there's basically 3 different commands. So the first thing we need to do is write the configuration file, and this is where you define all the resources. We just saw an example of this. You want to create all of the elements you need, and you do that with the command terraform refresh. And this will go out and talk to the different infrastructure providers. It's going to ask them what is currently out there, what's currently running, what's the current state, and it's going to, this is where like the first step, right? Like what is currently out there. Next, you're going to run an execution plan with the command terraform plan. And so in this stage, Terraform figures out what it needs to get your current configuration to the desired configuration. So let's say you write in your configuration file, I want to create this network on GCP, or I want to create this database on AWS, whatever it is. What you define in your configuration file, that's your desired configuration. When you run Terraform plan, Terraform says, in order for me to execute this plan and make your desired configuration the actual configuration, this is what I need to do. I need to create this resource. I need to update this resource. It's the execution plan. It's basically, think of it as like a diff, like a git diff of like the differences between what's existing now and what you want to update. And then we have Terraform apply. This is where Terraform performs all of the proposed operations and executes the plan. It figures out what the right order is to create all the resources, and it executes that plan. So it makes your desired configuration the actual configuration. And there's a couple of parts to Terraform that are essential to the way it works. So first we have Terraform core, and core is responsible for a few things. It takes in that configuration file, again, which is provided by us, the user. It also takes in the current state, and this current state acts as the source of truth for our environment. Terraform uses the state file to determine the changes that we're going to make to our infrastructure so that it'll match our configuration. And this, again, this state file maps real-world resources to our configuration. It keeps track of things like metadata. Core is also responsible for how different pieces relate to each other. And then on the back side, we have providers. And providers are how Terraform connects to the rest of the world. And these could be cloud providers like AWS, Google, Azure, Linode, Akamai. They could be on-prem infrastructure like VMware. They could also be platform as a service tools like Heroku or Kubernetes. Other things Terraform could manage are software as a service. So there's also like very high level things like monitoring with like Splunk and source control with GitHub. And these are all externally managed services, but what's great about Terraform is that it understands that all of these pieces are related and all these pieces are connected. And so you have all these pieces of important infrastructure, and you can't deliver your application without your infrastructure as a service, your platform as a service, your software as a service. They're all part of your logical end-to-end delivery. And when you use an infrastructure as code tool, you get this single unified delivery of all of these components. And me as a developer, like I don't want to have to use one tool for my infrastructure, one tool for my observability, and one tool for every service that I add to my application. I don't want to have to like piece together all of these things. Instead, I want one place where I can have a holistic view of my application and what's going on all sides. So let's talk about kind of the adaptation of infrastructure as code. So let's talk about how do you start? So on day one, you go from running nothing to running something. And this is where you provision your initial set of infrastructure and you describe what your desired configuration is. So when you run Terraform refresh says, hey, there's nothing existing. And then when you run Terraform plan is going to create that execution, and then apply is going to go out and create everything for you because, again, this is day one, there's nothing there. Then there's the more challenging day 2 plus, and this is where you have your existing set of infrastructure and you're trying to evolve it, you're changing it over time, you're adding new services, you have existing infrastructure and you enhance it by adding these other elements, and you rerun that exact same workflow. Now, there's many moving pieces to infrastructure. Maybe one day you have a Lambda function. Maybe one day you add a database. Maybe one day you remove that database. Maybe one day you add a server. So you can imagine, like, over time, your infrastructure is going to expand and evolve, and you'll likely add different pieces. You're going to add more complexity, decrease complexity. And you have this process that you can use that's not going to change no matter where you are in the evolution of your life cycle. So then on day N, maybe in the future you decommission your infrastructure. Maybe these resources were for a test environment, or for some reason you don't need that infrastructure anymore. You can remove them with Terraform Destroy, which is basically a specialized version of Apply that will talk to those providers and destroy those elements. So there's many advantages to this workflow. What's great about Terraform is that your day 1 experience is identical to day 2, right? So it's something that you're going to keep doing, you're going to keep evolving, but you don't need separate processes for each stage of development. Another advantage is on day N, where you maybe you don't need this infrastructure anymore. You have the option to destroy, which cleans up your environment. And so in this life cycle, you go from running nothing to running something, and you evolve this day over day, and then you can decommission it. So as your team grows, it can be challenging to manage your infrastructure. And so normally companies will start with a single individual practitioner who's creating this configuration file locally, right? Like there's one person, they're like the DevOps person, and their workflow will start with writing some Terraform configuration. And then they'll go through that process that we talked about, and it's one person, and they're going to continue to evolve that infrastructure by themselves. And now, what if you go from running from a single individual to now there's like multiple teams? Maybe now you have like a DevOps team, and other people want to collaborate on managing the same infrastructure. So how do we make sure we have a consistent view of what the current configuration is and make sure we don't step on each other's toes, right? Because we're going to be making multiple changes in parallel. And what we do is there's something called Terraform Enterprise, which you still write your configuration and you plan it locally, but now you push your plan into a version control system, something like Bitbucket or GitHub. Basically, you move this to a central repository where you're managing this and you're coordinating the changes. And then your company does really, really well, and maybe you have a lot of teams that are working on your infrastructure. And so there's people who don't necessarily need to know about all the parts of your infrastructure. Like maybe there's new developers, or maybe there's like, I don't know, some business people who don't need to know every configuration for every piece of infrastructure. So what you can do is use something called a module. And a module is like a black box of infrastructure. And what happens is you define a set of input variables that let you toggle the behavior of the module, and the module might emit a set of output variables. So basically it's a container for multiple resources that are used together, and they can be used to create lightweight abstractions so that you can describe your infrastructure in terms of its architecture rather than in terms of its physical objects. So basically you can manage a group of related resources as if they were a single resource. And what you're doing here is you're encapsulating the complexity and you're making it more accessible to a broader audience, because a developer might not need to know all of the details of every part of your infrastructure or of one specific part. And even for like, if you're following the principle of least privilege, like it might be better for some people to use this module. Now, how do we manage all of these modules? Well, something that you can do is publish them to a central repository, and there is a central repository that exists today, and it's called the Terraform Registry. So if you go to registry.terraform.io, it's the global public registry, and you're going to find common forms of infrastructure, common architectural patterns. And what's great about this is that most of them are published by the cloud providers themselves, and it just makes it so much more consumable for us to go in and, I don't have to know every detail of how to create a Lambda function and everything that happens in the backend. I can just go into the registry, type in Lambda function, and find the code that I need and copy and paste it into my registry. So I can go in and say, I want this network from Google, and fill in a few of the inputs that matter, and then let the module take care of the complexity. Another benefit of using Terraform is that you can do multi-cloud deployment. And nowadays, I think it's very rare that companies are using only one cloud provider. So one of the benefits of this, when you provision your infrastructure across multiple clouds, is that it increases fault tolerance. You have more graceful recovery if like one cloud provider has an outage. And it also simplifies like the management and orchestration of these infrastructures when you're using a tool like Terraform. So just another benefit. So I just quickly want to recap before we get into the tools. Infrastructure as code, like why do we use it? Why is it beneficial? What are the advantages? So first, it enables everyone to be able to self-service their infrastructure regardless of your DevOps experience. You can implement the principle of least privilege, and use modules for people who don't necessarily need to know like all the physical details of the infrastructure. You also get this natural progression from day 1 to day 2 plus to day n, and you don't need to change a lot about the existing processes. When you use infrastructure as code, you get this single unified delivery of all of your infrastructure as a service, platform as a service, software as a service components. And again, I don't want to have to use one tool for my infrastructure, one tool for my observability, and one tool for every service that I add to my application. I have this one single unified delivery of all of these components, and I get this really holistic view of what's happening in my application. You can import your existing infrastructure if you didn't start building with this. You can do multi-cloud deployments. You can also optimize your cloud costs. There's a lot of stuff on pricing with, I know like Terraform just changed their pricing, but it is an open source tool that you can go in and start using. Okay, let's talk about tools. So there's so many choices when it comes to infrastructure as code tools. We talked about Terraform a little bit. One of the differences between Terraform and the other tools that I talked about is that Terraform allows for multi-cloud deployment. So you can deploy a database with GCP and an instance from Linode all in the same configuration file. They also have a registry with pre-made resources that's written in the correct language for those configuration files. AWS has two different infrastructure as code tools. There's CloudFormation, which is used for non-serverless resources, things like EC2, RDS. And then the second one is SAM, the serverless application model, which is used for serverless resources. And these are things like Lambda functions, DynamoDB tables, SQS queues. One of the biggest differences between Terraform and CloudFormation and SAM is that in your AWS configuration files, you can only add AWS resources, whereas with Terraform, you can have more than one cloud provider's resources. So if your entire stack is on AWS, then yes, you should use an AWS infrastructure as code tool. AWS configuration files are written in either YAML or JSON. Google Cloud is another cloud provider you can use. They also have templates. They also have an integration with Terraform. You can use a scripting language like PowerShell, and PowerShell has something called the PowerShell Gallery, which is a central repository for sharing and acquiring PowerShell code, and you can add resources from other cloud providers as well, so that's a plus. So some things, and then, there's also Ansible, which is more of like orchestration, which you can use with Terraform. So, you can use different tools for different parts of your infrastructure if that's something that you want to do. So some things to think about when you're choosing an infrastructure as code tool. Are you using services specific to that cloud provider or external services as well? And do you want your configuration file written in YAML or JSON or a scripting language like PowerShell? Are you doing multi-cloud deployment? Things like that. And the most important thing to take away here is that it doesn't matter what tools you're using to provision and configure your infrastructure. I just want you to capture this process in a way that can be repeated and automated, and that's going to make your life a little bit easier. So let's go through a quick demo. I want to do this with a Linode Terraform provider. So the first thing we have to do is you need to have a Linode account and you need to install Terraform. I'm gonna post the QR code to this at the end so that you can go in and create a Linode account and install Terraform. It'll go through everything for you. So if you don't have an account, you can create one for free and then you can install Terraform. It's an open source tool. So the first thing you have to do is generate an SSH key, and this is how you connect to the server. And you use the command SSH keygen. And then you have to copy your SSH key, copy it and save it because we're going to add it to our configuration file. Next, from your Linode account, you need to create a Linode API token. From your profile, choose create a personal access token. Choose the access levels, and then again, copy this because you're going to have to put it in your configuration file. So next, we need to create your configuration file and save it as a .tf file, and that's how Terraform knows what to look at. So the easiest way to do this is to type nano in the file name, and then you're going to insert your API token, you're going to insert your SSH key, those are the two that you just created, and then you're going to enter your root password. So the resource that we're creating here, this is a Linode instance, and we're calling this Terraform Web Example, and you can see these are the configurations that we're using. We're saying this is the region, this is the type of instance. At the top of the page, you can see that we're using the Linode provider from Terraform. This is all from the Terraform registry. And again, you can copy and paste this from the Terraform registry. So once we deploy this, we're going to see this Terraform web example inside of our UI. Next, we run Terraform init, which is going to initialize Terraform. Next, we run Terraform plan, which is going to create that execution plan. So what's the difference between what's currently in production versus what I'm trying to update? Next, we run Terraform apply, and it's going to apply our changes for us. And then once we log into Linode, we're gonna see this Terraform web example created. So this is just a very simple example of building your infrastructure with Linode and Terraform. Again, here's the QR code where you can go in. If you have not used the Terraform registry, I highly recommend. It's registry.terraform.io. There's so many different providers, so many different resources from different providers that you can use. And you can use Linode for those cloud resources. We do have a free version, so there's also some more resources you can use on YouTube. If you go to youtube.com/Linode, we have a great DevOps community, linode.com/blog. Terraform, again, is an open source project you can contribute to. This is my Twitter account at Talia_Nassi. I also just created a blog and a website. It's called buildwithtalia.com. Thank you all for joining, and please reach out on Twitter if you guys have questions or comments, and have a great day.